Greetings and welcome to my new calculus channel. My name is John Gabriel. So I'm constantly trying to help students understand mathematics better and learn how to perform the basic operations better. So what I'd like to do now is show you what happens when mainstream academics try to teach division. So I got to this result by typing best way to teach division, and this was the third video. Now, I chose this video because it's got two interesting ways to do it. And so, what the video says is that you could do it by sharing equally, as shown on the left here. In other words, you can draw three groups and then just manually count to 15, giving each group one particular object from 15, one number from 15, right? So you go 1, 2, 3, 4, 5 until you get to 15. Of course, if there's any remainder, then it's not going to be in these groups. It's going to be outside of the group. But the problem with this approach is that it's easy to do when you have fractions that are whole numbers, okay? In other words, the counting numbers or natural numbers. So it's easy to do when you have whole numbers. But these are also fractions, by the way. These are all these fractions. There's no number that isn't a fraction. All numbers are fractions. So the first part shows you a shared equal method. And the second part is actually more interesting because this woman or this educator has called it skip counting. So she starts off with what needs to be measured and she just keeps adding it to itself. So that's one of the ways you can find out how many times 3 measures 15, okay? Because 3, 6, 9, 12, 15. All right, so we've measured 15. You could have also done it the other way. You could have said 15, 12, 9, 6, 3. In other words, not using addition but subtraction, because division is defined in terms of subtraction and addition. Okay, and addition is defined in terms of subtraction. You cannot define subtraction in terms of addition only. So I've referred to that in previous videos. Okay, so your operator precedence is as follows. You have minus, then plus, then divide, and last is multiplication, okay? Because multiplication is a reciprocal process of measure, of division measure. So now, the better way is this method. And I took the chance to ask GPT. I said, let's talk about why the idea of division being taught as sharing equally is problematic and why it's much better to follow a consistent route of measure throughout all four basic operations. So the idea of teaching division as sharing equally is problematic for several reasons, especially when contrasted with a consistent approach grounded in the concept of measure. So here's an analysis. The problems with sharing equally is that you have an inconsistent foundation, okay? What that means is it introduces division as a distinct concept, which is unrelated to the principles underlying the other operations. In other words, it come before it. And of course, subtraction should come before addition and multiplication last. This creates a disjointed understanding of arithmetic, making it harder to grasp the unity of mathematical operations. So just take a minute and think about that. You can stop the video, go grab a cup of coffee, and come back. Then, there's ambiguity. The phrase sharing equally is situational and imprecise. Why? Because it applies primarily to real life scenarios, like distributing candies, which may confuse learners when they encounter abstract or fractional division. In other words, dividing by non-integer numbers or by ratios. So what that means is how would you apply the shared equally method if you had 3/8 divided by, let's say, 5/17. How would you apply that there? I mean, you can't easily just, what are you going to do there? Are you going to draw half circles, which are 5/17 of the circle? It's not like what she showed you when she said 15 divided by 3, where you had 3 circles. What are you going to do in this case? You can't use this method with anything but whole numbers. So it's really a crap method, okay? Shouldn't be taught because you want consistency across all numbers. So it also happens to have limited applicability because, as I just said, it works, as ChatGPT just said, it works well for integers, but fails to provide a clear conceptual pathway involving fractions, decimals, or ratios. And of course, the biggest problem, which is mentioned last year, is the disconnect from ratios. Division fundamentally involves ratios, just like every number, by the way, which are relationships between magnitudes. So teaching division as sharing equally obscures this intrinsic relationship, undermining deeper mathematical comprehension. So then it comes to the measure-based approach to division. So a measure-based approach views division as a process of determining how many times one magnitude fits into another, okay? That's the measure-based approach. In other words, if we have 15 blocks, oops, and I'm not going to draw all of them, okay, then we treat 3 as the unit, okay? So this becomes a unit all of a sudden, and we measure this as 1, 2, 3, etc., okay? That is consistent across every type of number. So, and a kid will easily grasp this concept because it's easy for them to take a measuring tape and place it against something that they're measuring and look at the measuring tape and see how far it runs along the length of the object. And so ChatGPT again gets the order wrong here between addition and subtraction. It's subtraction and addition, not the other way around. These operations represent combining or separating measures of the same kind. They rely on the assumption that measures being added or subtracted are commensurable. Well, let's just see why is it we can say P minus Q, right? Or let's actually take numbers. We can say 3 minus 2 is equal to 1, right? 3 minus 2 is equal to 1. But now let's say we want to go the other way and say 1 plus 2. Okay. This can be defined in terms of the minus operator. How? Like this. Okay. Now, you can go the other way, by the way. Okay. You cannot, for example, say 3 minus 2 and then only using the plus operator on the side find the answer. There's no way to do that. What does that tell you? That tells you that addition comes after subtraction, okay? Because you cannot say 3 and 2 here, and no matter how you put the pluses here, it's not going to give you 1, okay? In other words, and you can't say something stupid like that, because that's circular. That means you've already done a subtraction operation. So ChatGPT, I'm not going to read it all out, but it goes into several reasons for the measure-based approach. It's a unified framework. All 4 operations are seen as manipulations of magnitudes and ratios, and there's conceptual clarity. They develop an understanding of division as inherently tied to ratios and measures, and so on. So, as a summary, it says division taught as sharing equally creates unnecessary barriers and misinterpretations. A measure-based approach, on the other hand, establishes division as part of a unified system of operations tied to magnitudes and ratios, which is not only conceptually consistent, but also paves the way for a deeper understanding of mathematics. That's exactly right. Okay. So, without further ado, don't waste your time on lots of YouTube videos. I'm going to place some links to articles that you can read, and also a link to my latest project, which explains all these things plus a lot more. And for a mere 10 euros or $10, depending on where you live, you're going to learn everything there is to know about arithmetic operations and number. And also, if you come to my channel and you click on any one of the videos, there's a little join button, which if you become part of members only, for a mere $4.99 a month, you have access to everything else that I don't normally share with the public. If you're not already a subscriber to my channel, please click subscribe and click like, and I'll be chatting with you soon. My name is John Gabriel. Till next time, goodbye.